With the truth in 2.5 minutes, you'll receive more understanding than all 4 years of high school math. What you're looking at is a 60-degree right triangle inside of the 1-inch radius circle, what they call the unit circle. But you're only getting half the picture. This triangle actually extends down into the full circle. And before it took place in the 1-inch radius circle, this triangle took place the same measurements in the full 1-inch diameter circle. They call this height sine and this width cosine. Sine and cosine is also the height and the width of the circle at that degree. With the radius, all right triangles can be formed in the circle in just 90 degrees. That's 1/4 of the circle. At the same time, the diameter is forming all the right triangles inside of the circle using 3 quadrants, 270 degrees of the circle. The 30, 60, 90 triangle is the only triangle that contains the radius and the diameter. And whenever the diameter is 1, the radius squared is equal to 0.25, 1/4. When we look at the opposite leg, this length squared equals 0.75, 3/4. So the height and width of the circle creates the triangle. So we use sine and cosine to solve triangles, because those numbers are base numbers from whenever the diameter hypotenuse is 1. So to solve this 45-degree right triangle, we would take 12 and multiply it by sine 45, because that was the height inside of the circle at 45 degrees. And because the circle is symmetrical, it mirrors itself. To solve this 1575-degree right triangle, we would take 12 and multiply it by sine 75, and 12 and multiply it by sine 15. Whenever the triangle starts to form, the width gets littler as it travels down, but the height starts little and gets taller, and at 45 degrees the height and width are exactly the same. So what we call sine 60 and cosine 30, well, this is sine 60 and this same height is over here at sine 30. We also use squares to solve right triangles, and the circle we use whenever we use the squares is the circle whenever the 60-degree portion is 1. It's a very important circle because the radius squared plus this portion equals the diameter squared. This is that circle, and all the squares are linked from this circle to another circle by its balance number, which comes from the reciprocal of the equilateral triangle height mirroring the diameter of the circle. And whenever you multiply the two together, it equals the 60-degree portion squared, which is 1 in this circle.